Hello students. So far we have been discussing about finite and infinite sets. Now we are going to the properties of the real line. There are two types of properties that we are dealing with. The real line is denoted by the letter capital R, contains the positive, negative, real numbers and zero, rationals and irrationals. Now we are going to discuss the properties of R. Instead of capital R, it is written like this. A script letter R is used for the representation of the real line in print form. For writing it easily, we are writing capital R2. Then we are going to deal with two types of properties of the real line. One set of properties are called the algebraic properties, and other set of properties are called the order properties of R. Order, algebraic and order properties. These are properties of real line. Properties are classified into two. Properties of real line are classified into two, algebraic and order properties. What do you mean by algebraic properties of R? What do you mean by algebra? You are studying another course, abstract algebra. What is that? It starts with the group theory. Definition of group. Group is a set together with an operation satisfying certain condition. That means it is about an operation and the conditions satisfied by the operation and the elements of the set. Here also, algebraic properties means properties due to some operations in real line. What are the operations in real line? There are several operations: addition, subtraction, multiplication and division. And you know that subtraction can be viewed as addition of the negative of the same given number. Therefore, the necessity is only for considering the operation addition. Among addition and subtraction, we take addition, and among multiplication and division can be viewed as multiplication with the reciprocal. Therefore, we need only to study multiplication. Therefore, we are going to study properties of real line with respect to the operations plus and dot. Plus means addition and dot means multiplication. That is about the algebraic properties. You know some of the algebraic properties of the real line, called the closure, associative, commutative, existence of zero, existence of negative, and with respect to multiplication, some properties like this, and some properties including addition and multiplication like the distributive property. We can see which of the properties are included as the algebraic properties of R under the heading under the section algebraic properties of the real line. Then after that section, we deal with order properties of the real line. What do you mean by order? Ordering the points of real line. What is order? You draw the real line like this. Real line, infinite towards the left and right. So we can put the arrows in the right and left to indicate that it is infinite to both sides. And at the mid of this line, infinite line, there is a point 0. Towards the right of 0, we have points which are positive. 1, 2, 3, etc. integers, and there are infinite number of points between 0 and 1, 1 and 2, 2 and 3, etc. And to the left side of 0, we have -1, -2, -3, etc. negative integers. Real numbers means not integers only. Therefore, there are infinite number of rationals and irrationals in between the indicated points. We indicate 1, 2, 3, -1, -2, -3, towards the right and left, and there are several infinite number of points between these two, any two of these integral values. And here we have an order. There is an order for the real line. What do you mean by the order of the real line? Towards the left of 0, we have the negative real numbers, and 0 in the mid of negative and the positive real numbers. Towards the right of 0, we have the positive real numbers. What is the order? Negative real numbers, 0, positive real numbers. And among the negatives, also among the positives, we can find some other order too. This is what do you mean by order properties of real line. First we are going to study about the algebraic properties. Then we study about the order properties of real line. Let us come to the algebraic properties of the real line with respect to the operations. We know that there are 4 operations in the real line: addition, multiplication, usual operations. Addition, we can define infinite number of operations. But for the real numbers, usually we are defining addition, subtraction, multiplication, division. After studying abstract algebra, you know that we can define different operations, and the operations, and an operation is denoted by the notation star. The plus that we write may have different meanings, may not be the usual addition symbol. Dot that we write may not be the usual multiplication symbol that we use for the real numbers. But here we are discussing only about the usual operations: addition, multiplication, subtraction and division. Of this, subtraction and division can be given in terms of addition and multiplication. So we eliminate that operations in our discussion and concentrate on addition and multiplication. Thus we are going to define the algebraic properties of the real line. Let's come to the properties. Here we have the set of real numbers denoted by this script letter R, and we have addition, which is denoted by plus notation, multiplication, which is denoted by dot notation. Then the algebraic properties are, there are some properties with respect to addition and some other properties with respect to multiplication, and some with respect to combining addition and multiplication. The properties which are called algebraic properties with respect to addition are denoted by A1, A2, addition. First letter is taken as the property name, A1. A1 is nothing but the commutative property of real numbers. You know that if A and B are two real numbers, then addition is commutative. A plus B equal to B plus A for all A, B element of R. ഏത് രണ്ട് റിയൽ നമ്പേഴ്സ് എടുത്താലും, റിയൽ ലൈനിൽ നിന്ന് ഏത് രണ്ട് റിയൽ നമ്പേഴ്സ് എടുത്താലും നമുക്ക് അവരുടെ സം എങ്ങനെ വേണമെങ്കിലും, ആ രണ്ടുപേരുടെ സം ഓർഡർ എങ്ങനെ വേണമെങ്കിലും എഴുതാം എന്നാണ് ഇതിനർത്ഥം. ഫോർ ഓൾ എ ബി എലമെന്റ് ഓഫ് ദ റിയൽ ലൈൻ, എ ആൻഡ് ബി ആർ എനി ടു റിയൽ നമ്പേഴ്സ്, then a plus b equal to b plus a, and you know that this is called the commutative property. I am not writing the name, you know that it is the commutative property. And the second one with respect to addition is denoted by a2, and it is the well-known associative property. Here we have sum of three numbers a plus b plus c, sum of three numbers a, b and c. We can associate the sum in two different ways. That is, first we are going to calculate the sum of a and b, then we get a real number and we can add c to that number. Here the association is between a and b, and this association will give the same result when we associate b and c together. Here we are calculating the sum b plus c first. Then add a with b plus c. Both will give the same result for all real numbers in the real line. For all a, b, c element of R, we have a plus b plus c equal to a plus b plus c. First association is with a and b. Second association is with the b and c. However be the associations, the final value will be the same. This is called the associative property. Then we have the third property with respect to addition of real numbers. This is the existence of the zero element. There exists an element 0 in R. 0 എന്ന് നമ്മൾ പിന്നീട് നൊട്ടേഷൻ ഉണ്ടാക്കിയതാണ് എന്ന് വേണമെങ്കിൽ പറയാം. 0 in R such that ഏത് റിയൽ നമ്പർ എടുത്താലും 0 ആയിട്ട് ആഡ് ചെയ്താൽ 0 അങ്ങനെയുള്ള നമ്പറിനെയാണ് 0 എന്ന് വിളിക്കാൻ പോകുന്നത്. ഏത് റിയൽ നമ്പർ എടുത്താലും ഒരു നമ്പറിനോട് ആഡ് ചെയ്താൽ ആ നമ്പർ തന്നെ കിട്ടുന്നത് പോലെ ഒരാൾ റിയൽ ലൈനിലുണ്ട്. അത് ഏതാണെന്ന് നിങ്ങൾക്കറിയാം. a plus 0 equal to a equal to 0 plus a. 2 plus 0 equal to 2. 0 plus 2 equal to 2. It is not only true for 2 but also true for every real numbers. If there is such a number, then it is called the zero of. In group abstract algebra also you have such a concept. Here that number is 0. Usual 0 in the real line. This is called the zero element. This is called the zero element. We call it as 0. This is called the zero element of the real line. And that name 0 element is associated with the definition of group. A plus 0 equal to a equal to 0 plus a is satisfied for all a element of R. That is a third axiom or third algebraic property with respect to addition. And the real number 0 is called the 0 element of the real line. Then fourth one is called the existence of negative element. Given any a element of R. Given any a element of R. ഒരു real number തന്നാൽ there exists. It is connected with the 0 element. There exists an element. There exists an element such that I can write the property a plus there exists an element sum with that element equal to 0, and since addition is commutative we can write it as that required element plus a is summine തിരിച്ചെഴുതിയെന്നുള്ളൂ. And you know that for the case of real numbers with addition the negative of that number is the number which satisfies this property. A plus minus a equal to 0 equal to minus a plus a. Then minus a is called the negative of the given element a, and this is called the existence of negative. Then some properties with respect to multiplication. I can define the properties some more fast. Then first one with respect to multiplication is denoted by m1, and it is also the commutative property ab equal to ba. Without dot we can write the product for all a comma b element of R. This is the first property with respect to multiplication. Multiplication 1. Multiplication 2. Second property is associative property. A യും b യും multiplication കൊണ്ട് associate ചെയ്യുക. A into b into c equal to a into b into c. A into b into c. Without using the dots we can write